asked to simplify this expression, and I put the Pythagorean identities off to the side. And cosecant and cotangent, they go together in those Pythagorean identities. It almost looks like this, just a little bit different. I can rearrange this identity. I can subtract cotangent squared from both sides of the equal sign. If I do that, I get 1 equals cosecant squared theta minus cotangent squared theta. Okay, so that looks just like what we have up here except for the negative sign. And one thing I've had my students check out is that sine is odd, which means sine of negative x is negative sine of x. And then cosine of negative x equals equals cosine of x. So cosine is even and sine is odd, we say. Now you might be thinking, how does that relate to cosecant and cotangent? You could test these based on these simple facts to see whether cosecant and cotangent are odd or even. Cosecant is 1 over sine, right? So that means if you were to plug in a negative value in for cosecant, you'd also get negative cosecant of x. Okay, because they're just reciprocals. 1 over sine of negative x, which is cosecant. This is cosecant of x. That's equal to 1 over negative sine of x. So in other words, cosecant of negative x equals negative cosecant of x. So here we can rewrite this as negative cosecant x, but it's being squared. That's what that 2 up there means. So I'm squaring this result. So it doesn't even matter that it's negative. It's going to be positive. And if you test the same thing for tangent and cotangent, tangent is odd, which means if you put in negative x into tangent, you get out negative tangent x. Okay, so that means cotangent of negative x is also going to be negative, but again, it's being squared. Cotangent of x. So squaring a negative would make it be positive, so we're back here. Just instead of a negative x, we have a positive x. These are being squared, sorry. Okay, so from rearranging this identity, we found out that cosecant squared of a positive variable subtracted by cotangent squared of a positive variable, that's equal to 1. So that's our simplification for this right here. Okay. Your problem is easier. Okay, your problem is easier for the homework question I assigned. You're just going to be using this one up here, and then you don't have to rearrange to figure out the reciprocal trig identities, whether they're positive or negative.